Okay, in lesson 6.1 we talked about converting an equation given in standard form to vertex form by a method called completing the square. Today we are talking about taking an equation that is given in standard form and changing it into factored form. So really all we're doing is referring back to last unit when we learned how to factor a quadratic equation. We're going to do that again and apply our answers, the values of x that we get, to real life situations. So first, a few notes. The first thing we need to be sure on is what is a quadratic equation. Quadratic equation. Yes, you can use the paper that you have. Quadratic equation is an equation in the form. Now what's for sure going to be true about this equation? What does every equation have?
An equal sign.
Has an equal sign. It's an equation. It has an equal sign. Something on one side equals something on the other side. Sorry about the fuzz here. Come on. Auto zoom.
This is a great video. Maybe start writing.
Hey. An equation in the form ax squared plus bx plus c equals 0. Where a and b are real numbers and a cannot equal 0. What would happen in this situation if a equaled 0? What would happen if a equaled 0?
Then it wouldn't. Well, A normally tells us whether it's like condition and Z, whether it's like up or down, but if it's 0.
Y'all know this answer. What would happen if a equaled 0?
Then the entire equation will be that whole entire term, the a's term would be gone.
This whole x squared term would be gone and it would no longer be quadratic. Okay? Linear. It'd just be bx plus c. Okay? But we're talking about quadratic equations. So in a quadratic equation there is an x squared term, whatever the number is in front of it. We don't need to worry about. It's a real number, but it can't be 0 because then it wouldn't be there at all. So there's a quadratic equation. Quadratic equations, another note, can be used to model many things in real life. They can be used to model the flight paths of a toy rocket, so a rocket that doesn't actually reach outer space, a rocket that is still subject to gravity, a ball, or any other projectile. Projectile is something that goes up and comes down in a symmetric parabola.
I actually don't have
Oh, you don't. Just give me a deal, wait up.
This model, so the model of a quadratic equation that's used to model the flight pattern of a projectile. This model can be used to determine when the projectile will land. So what goes up must come down, and we can use a quadratic equation, which is being converted into factored form, to learn where this projectile is going to hit the ground. And that is what we are working on today. We do this by factoring the quadratic equation. We do this by factoring the quadratic equation. So if we consider the factored form of this polynomial, it's x minus 3 times x plus 5 equals 0. So what we have here is two factors. We have the factor x minus 3, and we have the factor x plus 5. And we know if we're going to multiply these two factors together, it has to equal 0. So what has to be true about this equation? Well, either x minus 3 equals 0, or x plus 5 equals 0. Or both of these. Either x minus 3 equals 0 or x plus 5 equals 0 in order to make the statement true, in order to make it a true equation. Okay? So look again at the definition for a quadratic equation. So at the very top of your notes, you had a note on the quadratic equation and what it looks like. How can you use factoring to solve a quadratic equation? How can you use factoring to solve a quadratic equation? Solving means find the value of x that makes the statement true. Find the value of x that makes the statement true. How does factoring help you? Well, we're not going to make x 0, but we are going to make each of the factors 0. So maybe just quickly it helps to look at what happens here. My goal to solving this equation is finding what values of x will make this true. Okay, so I know that either this is true, or this is true, or both. Okay? So over here, I need to find the value of x. Well, to find the value of x, I just need to add 3 to both sides. I get x by itself, x equals 3. So if I make x equal 3, this statement will be true. Or I can look at this one. I just subtract 5 from both sides, and I'm left with x equals negative 5. So this statement is true when x equals 3 and when x equals negative 5. And those are solutions to the quadratic equation. Those are the solutions. They both make the statement true. Either one or both of them. Doesn't matter. Okay, when we're talking about the solutions to a quadratic equation, another word that we use there is the word root. The root, and in brackets, of an equation. What is the root of an equation? Well, like we said, it's just another word for, it's the same as the solution of an equation. So what is the solution of an equation? Well, the root or the solution of an equation is the value of the variable that makes an equation true. The value of the variable that makes the equation true. So when we had something like y equals x squared plus 4x plus 4, there's two variables, and we could sub in any value for x, and we could get a value for y. Okay? But now we're working with something that looks like this. 0 equals x squared plus 4x plus 4. This is our quadratic equation, and it equals 0, so there's only one variable, and the solution to this problem is the x, or there could be two options for x, that makes the equation true. So because there is something that it has to equal, we're not just finding out what it equals when we put in an x, we're finding the x that makes this true. There's only one sometimes 2 solutions, sometimes 0 solutions. We're going to...
X or another O or Z?
0, sorry. Okay, so example 1, we're going to be solving by factoring. We have a quadratic equation given here, and solving means find out what x is, what x value will make this true. And we're told right off the bat that we can do it by factoring. So let's use our skills. How would we factor this equation? Well, we can factor by splitting up this middle term. We can do our skills using our product and sum. So here we have a sum of 9. We have a product of 14. What two numbers, what two integers multiply to 14 and add to 9? Well, we've got positive 7 and positive 2. So if I'm going to factor by grouping, I can split this middle term, the plus 9x, I can rewrite as x squared plus 2x plus 7x plus 14 equals 0. I have not changed the value of the left side, and so I'm allowed to do this without changing the right side at all.
How do you know when you're supposed to do that?
How do you know when you should use that versus another method?
The only time you wouldn't use this is if you had a perfect square trinomial or some other pattern that you immediately recognized. But this will always work. Yeah? Okay, so here we have our polynomial on the left side is split up our middle term into 2x and 7x, which means I can factor out of these first two terms, I can factor out x, which leaves me with x plus 2. And of our second two terms here, we can factor out 7, which leaves us with x plus 2. And now I have two terms, and out of the two terms I see a common factor, so we can pull out our common factor of x plus 2, which if we pull out x plus 2 from this term, we're left with x, and if we pull it out from this term, we're left with 7. So we have now factored our equation. We've rewritten the left side in factored form, which tells us that in order for this statement to be true, either x plus 2 equals 0 or x plus 7 equals 0. Now I have two little equations and I need to solve for x. So over here all I need to do is subtract 2 from both sides. X equals negative 2. And over here all I have to do is subtract 7 from both sides. I get x equals negative 7. So there are the two solutions for this quadratic equation. Now if we want to check our answers, which we're going to do, all I have to do is take my answer for negative 2, let's say for x equals negative 2, all I have to do is sub that back in to my original equation and see if it ends up being true. So I'll rewrite this. We have negative 2 squared plus 9 times negative 2 plus 14. Negative 2 times negative 2 is positive 4. 9 times negative 2 is negative 18 plus 14, and if I add all this up it does equal 0, so I've checked it, and x equals negative 2 is a solution. It is a root of the equation x squared plus 9x plus 14. Let's go ahead and do the exact same thing for our second answer, which was x equals negative 7. All I have to do is sub it back into my original equation. Negative 7 squared plus 9 times negative 7 plus 14. Multiply it out. I have negative 7 squared, which is positive 49. I have 9 times negative 7, which is negative 63. And I have positive 14. This does equal 0. So I've now checked that my factors are correct. X minus 2 is a solution to the quadratic equation, and x equals negative 7 is a solution to the quadratic equation. In example 1b, we're given the quadratic equation 2x squared plus 5x equals 0. We notice that we have an ax squared plus bx, but we don't have any c. So c is 0 here, but that's okay. We still have two terms. They can still be factored. These are already grouped because there's only two terms. So we can factor these just by pulling out a common factor. So what is the common factor between 2x squared and 5x? Our common factor is, I can't pull out the same number from the numerical side of the term, but I can pull out something from the variable, and I can pull out an x. So right off the bat, I can pull out an x. Sorry, it's going to be small this round. Leaving me with 2x here plus 5 here, which equals 0. Still, the right side has not changed. So now we have two factors, one factor here and one factor here. So in order for this statement to be true, either x equals 0, our first factor, or 2x plus 5 equals 0. And we are solving for x. So this side is already done. One of our solutions is x equals 0. Our other solution takes 2 steps of work to get to. First, we subtract 5 by each side because we're using bedmass in reverse when we're solving for x. We're using bedmass in reverse, so first we have to take out anything that's not connected to the x. We're going to subtract 5 from both sides. We get 2x equals negative 5. And then in order to get x by itself, we need to divide both sides by 2. So we're left with x equals negative 5 over 2. And you can leave that as a fraction. It's the easiest way to deal with it. Well, let's go ahead and check if our solutions are correct. Check. For x equals 0, we sub 0 in for x in both places. And that's a quick check. 0 times 0 is 0. 0 times 2 is 0. So this whole term is 0. And 5 times 0 is 0. 0 plus 0 is 0. Boom. X equals 0 is a factor. We've done that correctly. 0 is a solution to the quadratic equation. Well, let's check what we get when we sub in x equals negative 5 over 2. So we've got 2 negative 5 over 2 squared plus 5 times negative 5 over 2. Negative 5 over 2 squared, that's just negative 5 over 2 times negative 5 over 2. Two fractions, top times top, bottom times bottom. Negative 5 times negative 5 is positive 25. And 2 times 2 is 4. And here we are adding. And now we have 5 times negative 5, which is negative 25 over 2. Top times top, bottom times bottom.
Does that say 2.5 over 4?
This says 25 over 4. It's 5 squared, 25. Okay, if we multiplied this out, we would end up with 50 over 4, or we could just go 2 over 4 right away. We could divide this and end up with 25 over 2. So 50 over 4 is the same as 25 over 2. So if I rewrite this first term, I'm going to run out of space. I'll draw it over here. We've got 25 over 2 plus negative 25 over 2 is just minus 25 over 2. Well, 25 over 2 minus 25 over 2 equals 0. So our two terms, our two solutions are correct. We've checked out x equals 0. We've checked out x equals negative 5 over 2. Example C is a little bit trickier. There's one step that we're going to have to do to set it up properly. We've got 6x squared minus x equals 15. Now this is an equation because it has an equal sign, but it's not in the proper form for a quadratic equation. What is wrong here? What is out of place? It doesn't equal 0. So our first step is to write in the form ax squared plus bx plus c equals 0. We've got to get it in that form. So how do I get
Do
it?
it a different way.
So how do we get it in that form? We're just going to subtract 15 from both sides. So now we have 6x squared minus x minus 15 equals 0. Now if we look back on our strategies for factoring the left side of this equation, what would our strategy be? How are we going to split up this middle term? How are we going to find our two factors?
Multiply 6 and 15 and find the factors.
Alright, so we've got our sum and our product. So we've got a sum of -1, and we have a product of 6 times -15, which is -90. Okay, so we're looking for two factors of -90 that add to -1. Any numbers that multiply to -90 and you think are different by only one integer? 10 and 9, right? 10 and 9. Which one is going to be positive and which one is going to be negative? Well, when they add up, there's still -1, so the bigger number has to be negative. So we've got -10 times +9. Yeah, that's the product of -90, and yep, it adds to -1. So now we can go ahead and group our terms. Now I can look at this and I can see right away that 6 is 2/3 of 9 and 10 is 2/3 of 15. So I'm going to put the 9 first. Also because I have a negative here and a positive here, it's nicer to keep them together, but it would work either way. Just if you did it a different way, you'd be left with a funny fraction, but the math would work out the same way and the answer would be exactly the same. I'm going to rewrite this as 6x squared plus 9x minus 10x minus 15 equals 0. Now I have not changed the value of the equation at all. What can we factor out of these first two terms? I can factor out a 3 from the numerical part of each term, and I can factor out the x of the variable part. So we are going to have 3x on the outside here, which leaves us with 2x. And out of this term, we're left with 3. Now in our next set of terms, we can pull out, looks like just -5, which is going to leave us with positive 2x plus 3. Remember, we're thinking, what do I need to multiply by -5 to get back up to -10x? Well, that's 2x. Or what do I need to multiply by -5 to get back to -15? Well, that's positive 3. And now we look at our two terms that we have. Here's a term, here's a term. They have a common factor of 2x plus 3. If I pull that out of my first term, we're left with 3x. If we pull that out of our second term, we're left with 5. That equals 0 when we have rewritten the left side of our quadratic equation in factored form. Now, either one of these has to be 0 in order for the statement to be true. So, either 2x plus 3 equals 0, or 3x minus 5 equals 0. Subtract 3 from both sides over here, I get 2x equals -3. Divide both sides by 2, we get x equals -3 over 2, or -1.5. On our second factor, we add 5 to both sides, leaving us with 3x equals 5, and we divide both sides by 3, leaving us with x equals 5 over 3. And there we have our two solutions to the quadratic equation. In our next example, we're going to see that if we apply this to a parabola, what we're actually finding is where the parabola crosses the the x-axis. Okay? You have example 2 written for you on the front of your sheet. Please read it with me. We're going to draw a picture to help us visualize, but what you have there is the path of a stone is thrown into a ravine. The path of the stone is modeled by the quadratic relation y equals negative x squared plus 5x plus 84, where x represents the distance in meters traveling horizontally, and y represents the height in meters above the surface of the river at the bottom of the ravine. So if we could draw this picture, we are standing at the top of a ravine, and there is water below in the bottom of the ravine. So just by looking at the equation in standard form, which is y equals negative x squared plus 5x plus 84, what is the height of the ravine? The height of the ravine is 84. So that's the height that we're starting at. What we want to find is how far does the stone travel horizontally before it hits the water. So let's say we're throwing it right from this edge of the ravine. So we can make that our y-axis. That's our starting place. And we know it's being thrown from a height of 84 meters, which is the height of the ravine, because it's being thrown from the top of the ravine, which makes the water level our x-axis. So this stone is going to hit the water at 0. When y equals 0, that's when it's going to hit the water. So if we could draw, I don't know what the parabola is going to look like right off the bat, but I'm going to guess it's going to look something like this. So right here, we're not worried about this information, right? When we solve, we're going to get 2 options for our solutions. Is this a possible solution? No, it's negative distance and it's not even landing in the river. Okay, so they're throwing it from here and it's coming out this way. It's going to land somewhere, and this point right here is going to give us our horizontal distance traveled before the stone hits the water. So that's what we're looking at here. We're given the equation. We need to put it in factored form so that we can find our 2 roots. So we can find our 2 zeros and then take the one that makes sense. So here we have our equation. We're looking at, we want to find out where does negative x squared plus 5x plus 84 equal 0. Where is that going to equal 0? 0 is where it hits the ground, where it hits the water. Okay? Well, the first thing we want to do here is you could either factor out a negative 1 in order to get this to be a positive coefficient in front of the x squared term, or because we're in an equation now that has a number on the other side, you can actually just divide each term by negative 1. And make sure if you're doing something to the left side of the equation, you do it to the right side as well. So if we divide each of these terms by negative 1, all that does is flip the signs. So we're left with x squared minus 5x minus 84 equals 0. And now we can use our factoring skills. We're looking for a number that has 2 numbers that have a product of negative 84 and that have a sum of negative 5. So we've got sum and product I can do over here. Sum of negative 5, product of negative 84.
Why did you switch the signs?
Because I want my coefficient a to be positive. Yeah. Okay, factors that multiply to 84. 84 and 1, those aren't going to work. 42 and 2, those aren't going to work. Is there a factor of 3 of 84. You could get out your calculator for questions like this. I am just going to skip ahead to the right answer.
Yes.
They are 7 and 12, but here we need to multiply to negative 84. So which of these is positive and which of these is negative? Okay, the 12 is negative because they need to add to negative 5. So here we go. I can split up this left side at the middle term of the left side, and it does not matter which order I do it in. We're going to be left with x squared, let's go plus 7x minus 12x minus 84. We've not changed the value of either side. We've simply rewritten it so that we can group and we can factor. Now I'm looking at our first two terms. What can I factor out of our first two terms? Factor out the x, leaving us with x plus 7. Now we're looking at our next two terms, and I can factor out negative 12 from them, leaving us with x plus 7, because negative 12 times 7 is negative 84. Okay, can take a common factor out of these two and then out of these two. The common factor here is x plus 7 and x minus 12. Now, if you are paying attention, you're ready to skip a step. And the step that you can skip is right here, 2 steps actually. If you know that the two factors that multiply to negative 84 and add to negative 5 are 7 and negative 12, well, look at what happened. X plus 7, x minus 12. All you need to do is plug them right into factored form and you'll be done. You can go straight from this step
So is it always the opposite?
to this step.
And then the same? Never mind. That's a dumb question.
So if one of your factors is 7, x plus 7. If one of your factors is negative 12, x minus 12. Okay? And that's easy to see because you know how to FOIL this back, in which case your last term will be negative 84, and your two middle terms will be plus 7x minus 12x, which is minus 5x. Okay, so in our next example, we'll be skipping those steps. Maybe not because it's a bigger problem. But okay, so what are the solutions here? Well, either x plus 7 equals 0 or x minus 12 equals 0. Here x equals negative 7 and here x equals 12. Those are the two solutions to the problem. But this is a real world situation about throwing a rock over a ravine into the water. So which answer do I neglect and which answer do I keep? Yeah, we can't have a horizontal distance of negative 7. You'd be throwing the rock backwards and into the ground. So this 0 is not relevant in our real life situation. But the positive 0 is the root of the equation. So as a final answer, the stone travels 12 meters horizontally, 12 meters horizontally before hitting the water. Stone travels 12 meters horizontally before hitting the water, and that is a real-world application of solving a quadratic equation by factoring and finding the roots of the equation. Example 3 you also have written for you. It is pertaining to the dimensions of a rectangle. We are going to draw a picture to match the information that we're given. So we're told that a rectangle has dimensions, here's my rectangle, of 3x plus 1 and 2x minus 5. Well, the dimensions of a rectangle are just the length and the width. I can see here that 3x plus 1 is longer than 2x minus 5, unless x is negative, but I don't think x will be negative. So I am going to, just for the sake of keeping track of things, I'm going to make the longer side 3x plus 1 and the shorter length 2x minus 5. It does not matter at all if you do this on a real problem. You will still get the right answer even if your diagram doesn't match. We're also told that the area of our rectangle is 1,150 square centimeters. 1,150 centimeters squared. Thankfully, we know that in a rectangle, area equals length times width. So all we have to do here is sub in our information for the area, which is 1150, our information for the length, which is 3x plus 1, and our information for the width, which is 2x minus 5. And no, it does not matter which order you write your two factors in, because multiplication is commutative. Well, we already have factored form, but are we in the correct form altogether? Yeah, we're finding our zeros. So this isn't equaling 0. This would tell us that in order to be true, 3x plus 1 needs to equal 1150, but that's not finding our zeros. So what we need to do here is convert this first into standard form, move the 1150 over, and then solve from there. So here we go. I'm going to first multiply out. We're going to use the distributive property to find out what this right side equals. I've got 3x times 2x, which is 6x squared. Then we have outer times outer, which is 3x times negative 5, which is negative 15x. Then we have inner times inner, which is positive 2x. And then we have last times last, which is negative 5. Group these guys together. My like terms, we have 6x squared minus 13x minus 5. And then here we can subtract 1150 from both sides in order to get 0 on the left side here. So you've got 6x squared minus 13x minus 1155. And now we're ready to factor and solve. I cannot pull out a common factor. This term is only divisible by 5 and 10, and multiples of 5 and 10. This term is only divisible by 1, 2, 3, and 6. So there is no common numerical factor. There is no common variable factor. So we need to use factoring by grouping in order to do this. If you find the sum two numbers that have a product of 6 times negative 1155 and they add to negative 13, you would have to do some guess and check there, but the two numbers are negative 90 and positive 77. It's helpful that we're given those. So we have 6x squared minus 90x plus 77x minus 1155. Now again, it will take a little bit of guess and check for you to take things out of here. But what you would do is you'd basically say, okay, out of this, I'd like to get that 6 out. And I know I can take an x out of both terms. So you could just do it in your head, or you could chuck it in your calculator. Is 90 divisible by 6? It is. 6 times 15 is 90. So I can pull out 6x from the first two terms, leaving me with x minus 15. And then again, I would go to the calculator and I'd say, okay, well, I know I want to be left with x minus 15 as one of my terms. So can I divide 1155 by 77? Your calculator would say yes. So go ahead and do that, which would leave you with x minus 15. Now I have two terms, and I have a common factor between those two terms. So let's go ahead and take out our common factor, which is x minus 15. And then from this term, we're left with 6x. From this term, we're left with 77. This is factored. So now what needs to be true in order for this equation to be true?
One of those has to be
0.
equal to 0.
Lovely. One of these factors has to be 0. So either x minus 15 equals 0 or 6x plus 77 equals 0. Over here, all I have to do is go add 15 to both sides. X equals 15. Over here, we have to subtract 77 from both sides. And then divide by 6.
You're down to
So the two roots of this equation are x equals 15 and x equals negative 77 over 6. Are both of these realistic answers? Think back to our original problem. The dimensions of...
the old negative 77.
Right, so my dimensions can't be negative. If I take this guy, x equals negative 77 over 6, which is about negative 13, and I sub that in here, I would get a negative dimension. You can't have a length or width of something that's negative. Doesn't make any sense. So this is not a real solution to the problem. The only solution is x equals 15, which we could use that information to find out exactly what the length and width are of our rectangle if we subbed it in. 2 times 15 is 30, minus 5 is 25. So the width here is 25 centimeters. Over here, the length would be 3 times 15 is 45, plus 1 is 46. We'd have a length of 46 centimeters. And that is how we use quadratic equations and factoring quadratic equations to solve for x. Here is your homework for lesson 6.2. You can find that on page 282. You will be doing number 1 and then number 4 through 8. And again, if that is not homework checked by Monday, we can hang out at lunch for a little bit.